All right, welcome to simplifying exponential expressions. So I'm actually going to take out this first part, put an example here. We got 3x to the fourth. The coefficient here is the 3. So when we say coefficient, you're always looking at the number that's multiplied in front. Variable is the x. The exponent is the fourth power. And expanded the variable exponent, so you have x to the fourth. To expand that out into multiplication, it's x times x times x times x. So exponents is just a simplified multiplication is all it really is. The zero exponent rule, anytime a number is, anything's raised to the 0 power, anything, it's always 1, equals 1. And we can explain it, I explained it during class. Product rule. So product rule means when you have like bases, what you're doing to the exponents with multiplication is you are going to be adding the exponents, so m plus n. So an example of this would be like x to the fifth times x to the third. Well, you can actually write this out if you want. 1, 2, 3, 4, 5 x's multiplied together. Bring that multiplication down, and then the x to the third means 3 x's multiplied together. Well, how many x's is that multiplied together? That is 8. So really all you have to do is just add those exponents. And that's the product rule. If you have coefficients in front, so if it was like 2x to the fifth times 4x to the third, you would multiply the coefficients together. So 2 times 4 is 8. And then x to the fifth, 5 plus 3 is 8. So 5 plus 3. Just add those exponents. Quotient rule. Quotient rule is the opposite of the product rule. So when you are dividing like bases, so we still got the like bases of the exponents, but now we're dividing. So to divide, you're going to have to subtract the exponents. So if I have x to the fifth and we're dividing by x to the third, you're going to subtract those exponents. So it'll be x to the, and what I do is I take the biggest exponent first. So I look at the biggest exponent and I subtract the smallest. The answer will always go where the biggest exponent was. So it's like your x is in the numerator, and we actually don't even need to divide by 1. If you have coefficients, so if I have like 6x to the fifth over, say, let's go 4x to the third, you treat those coefficients, those are just like fractions like you did in 5th grade. You're going to simplify them. So 6/4 you can divide by 2, divide by 2, and you get 3 over 2. X to the fifth divided by x to the third is you're going to subtract those exponents and be x squared. If this doesn't make a whole lot of sense, there's another way you can write it out, expand it out if you want. I used to do this sometimes when I forgot the rules. 1, 2, 3, 4, 5 over 1, 2, 3, x to the third, and I used to cancel them out like this, leaving me with x squared in the numerator. So you can do it that way too. The power to power rule, or exponent to exponent. This is when you have an exponent being raised to another exponent. And what we do here is you multiply. So if I have x to the fifth to the third power, I see the exponents kind of next to each other here with the parentheses. That means we multiply. So it's going to be x to the 15th. Now if I have a coefficient that's involved, so if I have, say, 2x to the fifth raised to the third, this is actually going to be what's going on down here, the product to power rule. So it is, I'm going to have, so I'll do that down here. So we have 2x to the fifth to the third. And what's going to happen is that 3 is going to go to the 2. So it's 2 to the third. And then it's power to power. So that's 5 to the third. And really, you'd be like, why are there different rules? There's not. It's really like there's a 1 here. So it's really 1 times 3. So you have 1 times 3 is 3. So that's 2 to the third. 5 times 3 is 15. And then 2 to the third is 8. X to the 15th. And the negative exponent rule. This one always gets people, but the main deal is we cannot have negative exponents in our final answer in math. Now science, that's a different story with the scientific notation and such, but with math we cannot in a final answer. To get rid of this. So if I have, say, negative x, or x to the negative 5, what we're going to do is, now that right now it's in a numerator, what we're going to do is we're going to take the base and that exponent, and we're going to move it. So it moves down to the denominator and becomes positive. And in the numerator, there's always a hidden 1 that's there, so that 1's going to stay there. If the negative was in the denominator, so if I have something like 3 over x to the negative 2, well, that x to the negative 2 is going to go up to the numerator, and it's going to become positive. Really, it's over 1. We don't even need that, though. All right, let's get to a problem or two. So number 1, we have x to the third times x to the third. Well, we have multiplication of like bases. We are going to add those exponents, so it's 3 plus 3 is going to be 6. On number 2, we have the product to power rule. So it's 2 to the 1 times 4 and n to the 2 times 4. So you have 2 to the 4th times n to the 8th. 2 to the 4th is 16. That'll be n to the 8th. Let's see here. Let's do one more problem. So if I see parentheses, we got to get rid of it first. So we're going to do the product rule here, or power to power rule. So it's going to be y to the 1 times 5 and 5 times 5 x. X to the 5 times 5. In the denominator, I can add some like bases. So x to the 4th, and it's multiplying, so it's going to be adding the exponent. It's going to be y squared times y. So that's y squared times y, so we add those exponents. So in the numerator, I have y to the 5th, x to the 25th, over the denominator is going to be x to the 5th, y to the 3rd. Now we have some like terms, like bases. We have the y's. I go with the biggest exponent first, so 5, and I subtract 3. My answer is 2. I'm going to put that where the biggest exponent was. My x's, I'm going to do the same thing. I have x to the 25, and I'm going to subtract to the 5th. So x to the 25th, 25 minus 5 is 20, so it'll be x to the 20th. And there is my final answer. The denominator is 1. I'm not going to even write it. So thanks for watching.